Thank you, Mr. Helmi. Assalamualaikum warahmatullahi wabarakatuh, and good morning, everyone. Thank you again, Helmi and UTHM FKE, for having me to sharing my a bit of what I know about neural network. But of course, dah ramai expertise kat sana tu, boleh share saja je dewan ni buat saya, okay? Alright, but I bet this one is not the first time for you to hear on about neural network. But I think now neural network mostly become like a benchmark method for any machine learning study. Okay, and I started venturing into artificial intelligence when during my undergraduate study. Of course, this Helmi and ada beberapa orang dekat UTHM tu, we are among the pioneer batch, Helmi, taking AI for at that particular time. But at that particular time, masa tu AI was kita kata vague, just a concept or idea of AI. But somehow we have interest to get into AI. Okay, semua orang have no idea kata AI ni mana ada future. What AI is all about? It's about robotic ke about apa ni? So at that particular time, the idea was just vague idea, very conceptual. But alhamdulillah, since now that the interest of AI is now growing. Okay, AI seems like a new trend now and be becoming norm. I think it seems like becoming a norm, like in computing. Alhamdulillah, I think after a few decades now in Malaysia, now people start to appreciate what it's all about, and everything is about AI now in computing. You can see, okay. All right. So this is the outline of what I'm going to share with you as neural network inspired from the brain structure. So allow me to share a bit on a neurobiological system, okay, how the structure of neural network is inspired from, okay, and what is learning in artificial neural network, what does it do actually. So we will see a bit on that, and then how to see artificial neural network from the perspective of predictive analytics, okay. Is it a tool, or how can we make get some benefits in order for us to have some feeling in this area. And then what we have been what we have found now, the one that in trend is the deep learning. Everything was deep learning now, okay. And the tools and frameworks, whether now we no longer need to code from scratch. Over there are lots of tools and frameworks that we can just adopt and adapt to develop any application. And then we walk through on some application using neural network, see the complexity and the challenges in developing such systems. So these are perhaps just a few guidelines that what I want to share with you today. All right. It's what I've mentioned. ANN, artificial neural network, is inspired from the anatomy or the functionality of the brain. In our brain, we have the region that control the movement. For example, we have specific region that control the that control any task, speech, understanding. So these are the some examples of the regions of the brain. Okay. Specifically, neural network try to learn or try to imitate, try to copy how the brain learning process. In particular, how do brain establish the connection between this neural brains perform this task, okay? And then looking into the neuron biological system, okay? So of course we have thousands, if not billions, of neurons in our brain interconnected to each other to perform certain tasks, okay? And this is this one single neuron from the billions, okay? So for each neuron we have dendrites in which to capture the input from the environment, and we have this nucleus or soma, people term as soma or nucleus or the cell body, in which to process the incoming inputs and to determine whether this particular neuron is going to fire or just idle. Okay, and then once the signal is processed and we get through the axon to relate to other neurons, I would say, okay, other neurons. So each neuron is connected with this special link, this is called name and a synapse. Okay, so in neural network, if you have come across on the term of Hebbian learning, Hebbian kan, the Hebb rules. So what is Hebbian learning? So the Hebbian learning says if one neuron fires at one particular time, A, for example, this neuron A fires, and also B also fires, let's say this B neuron fires, so there is some correlation between these neurons. Means strengthen the synapse or to decrease the strength of the synapse. So that is the purpose of learning. So this is how the computer scientists come up with this idea of artificial neural network, inspired by this one, by the structure of neuron. We have dendrites to become input, and we have synapse to represent the weights, and we have the cell body to process the incoming input, and we have the axon. Okay, we'll see the detail. Okay, as I mentioned, we have dendrites. This is dendrites. We have perhaps thousands of dendrites interconnected here. So the function of dendrite is to extract the input from environment, or to receive input from environment or from other neurons. Okay, and then this signal captured by the dendrites captured. Then this we process by the cell body, or sometimes we term as soma or nucleus. Nucleus is act like a central processing unit yang akan proses all the incoming signal. Okay, and this cell body or this nucleus, if the sum of the incoming signal is strong enough, so this neuron will fire. Kita kata neuron fire, means neuron will excite, dia akan aktif. Okay, and then the activation signal will be relayed to other neuron through axon. This one is axon, just to relay the output. Okay, and then whether when neuron A fire and then later comes neuron B fire, it depends on the strength of the connection between this neurons. Okay, so that is basically from the structure of a neuron, the neuron biological system. So we have dendrites, we have axon, we have the nucleus, and we also have synapse to connect the neuron. And they come up with this artificial neural network, to artificial neuron architecture. So we have dendrites and we have input layer to represent the role of dendrites, and then we have synapse, which is the weights. Okay, synapse to connect between one neuron and to another neuron, and the computer scientists has also come out to model, how to compute the incoming signal. Okay, how to compute the incoming signal and to interpret whether this, and to determine whether this neuron should fire or just silent or idle. Okay, that is the idea of neural network, artificial neural network. The computer scientists have coined out this idea from the neurological system. So it have this input layer, and we have this output layer. So in the middle we have synapse. So the most important elements in neural network is the synapse, because this synapse will determine how good is the learning. Okay, so we will learn later on how to how to perform the learning via doing the synaptic plasticity. We see later on. Okay, and so from if I'm not mistaken, from its first year of introduction, I think 1960 something. Okay, so the model have evolved to a few generations. Okay, started from the first generation of neural network, which is a simple model, the Macaulay-Pitts model, we call it. Okay, it just only have input, okay, and the output. Just simple. It only meant for I would say linear problem only. Okay, due to its simplicity, it's only meant for, it can only solve problem with only linear problem only. You have only few variables, and the linearity in the data is just only linear. Okay, and then later, after we came to realize there is some needs to solve more non-linear data, more complex data that involve more complex learning. So it came to the second generation of neural network. If you have come across term multi-layer perceptron, dia asal daripada single layer, and they invented the multi-layer perceptron to cater the non-linearity in the data. Okay, so I think the popular algorithm so far for the second generation is, if you have got back propagation learning algorithm, yang tu memang dah legend punya algorithm, back propagation learning algorithm. So in the second generation, it improved the other model, the error optimization, ada penggunaan error. So it suit well for more complex data, for more compared to the first generation. It can only solve the linear data, and in the second generation it can complex more. It can deal with more complex data. For example, the non-linear data. Okay, and then later they introduced the second generation. Third generation. So from the second we move to the third generation. In the third generation, the key element is the time. Previously, if in the original help learning rules, if neuron A fires and neuron B fires at the same time, so there is some correlation between them. But in the third generation, it deals with the fact that there actually in our learning, in human learning, there is some delay of neuron activation. It's not necessarily neuron to be fired at the same time. Only there's the correlation, but we allow some time frame for the neuron to be fired. For example, if neuron A fires at a particular time T1, and then after some period of time, neuron T2 fire within some acceptable range of time, so there is still exists some correlation, some connection, okay? And this third generation neuron, so due to the time element, so this third generation neuron best deal with time series data, okay, time series data. And people say the third generation neuron is more biologically plausible. Dia kata lebih dekat dengan human because this one it's like human neuron firing because actually there's no exact time of neuron fire. Dia ada some delay. Macam-macam lah the neuroscientist claim. So it depends. Depending on the application, so people are still using the first, second, and the third. It depends on the application that you want to pursue. Okay, so this to see how the evolution of the neural network. Okay, some aspect of the evolution due to the complexity of the data, and some of the result of the evolution due to the moving towards to more biologically plausible neural network. Okay, so this is the generation. But I think until now, the most popular use is this one, okay? The multi-layer perceptron with backpropagation algorithm. That one is almost to be applied as a benchmark method in any machine learning study. Okay, and then let's see how do we do learning actually in the artificial neural network. Okay, let's walk through this example. So of course, data is a must. We need a data, a historical data in which we want to learn or want to obtain a model in which we want to use this model to predict the future. Okay, the data, of course, it consists of attributes. Okay? For example, this one is data about what? Heart attack. Okay, we have age, gender. So those are the attributes with their values. Okay, depends on what the data is all about. So we need to have a good or a set of relevant attributes in order for us to do some tasks. For example, to perhaps to classify whether this particular patient to have heart attack or no, there's no heart attack. Okay. And then the ultimate goal of learning in neural network is to find the weights in which to explain the contribution. For example, the contribution of age, how much age contribute to heart attack, how much the gender, sugar, and hypertension to contribute to heart attack. So the ultimate goal of learning in neural network is to find the strength, the weight strength here, the age, gender, sugar, and in order to that contribute to the class decision. This one we call the class decision. For this case, the class decision is the heart attack. Okay. So after a few cycles of learning, so finally we get a set of weights. So and later we use this weight to predict the future. Okay. After we have a good strength of age, gender, sugar, and hypertension already done. Okay. And let's say we have this new data using the model that we have obtained from the learning. So yes, we can now predict whether this particular person is yes or no to heart attack. So that is basically the idea of neural network. Okay. Finding a set of weights, okay, from a set of data, in which later to use these weights. Weights is actually to explain the association, or in statistical we call it the correlation value between x and y. Okay, the correlation value. For example, how much each the strength of weight in terms of its contribution to heart attack, gender, so on and so forth. Okay, that is the idea of learning. So in any algorithm of neural network, the ultimate goal is to find a set of weights, be it clustering ke, algorithm clustering ke, or classification. It depends on the task. So, but at the end of the day, the one that we are looking into is the weights, a set of weights that we want to use to predict or to perform any task for the future data. That is the whole idea of neural network. Of course, we have thousands of algorithms. What has been different from one algorithm to another algorithm is the way they update or the way they obtain the weights. Is the formulation macam-macam lah orang introduce. Okay, right. As I mentioned, okay, the goal is to get the weights here, the W1, W2, and WK, for example. Okay, okay. In a simple calculation, generally we have input layer here and we have output layer, and mathematically speaking, we just total weight this one. Okay, the value of age we multiply with W1 or the connection, and the gender we multiply here, so that we have the incoming signal here. So if the incoming signal is strong enough, so we use this activation function to interpret if the total weighted signal is strong enough to trigger this output, whether this heart attack and no heart attack. So that is the rule of this one activation function. This one is to model. Remember, there's the nucleus or the soma, the cell body, the central processing unit. So this function will determine the activation of the output. In this case, whether this heart attack or no heart attack is to be activated in order for us to predict any new data here. Okay, so still again, the goal is to get the set of weights in the learning. Okay, in any kind of neural network learning, the goal is to set this set. Itu yang penting. Okay. All right. So let's walk through an example. Let's say you want to predict an application. So this is a classification problem. We want to classify is an application of student, whether to stay in college, okay, whether the application is to be accepted, KIV, or rejected. This is to walk through a simple problem. Okay. Of course, we need to have a raw data that we have gained as a historical data that we have obtained from the past observation or from the past records. Okay. So this is raw data. So perhaps there are some, but this one, when you say raw data, perhaps the data is noisy. So we use it. And like other machine learning technique, neural network also requires to undergo some sort of data preprocessing. So we have to make sure that the data that we want to use, we want to fit into the learning algorithm is clean, error-free, okay, and as clean as it can. So perhaps we want to remove any unnecessary attributes, any not meaningful attributes. For example, here metric, okay, how come kita kata cerita data preprocessing itu memang satu topik tak habisnya, memang banyak juga data preprocessing. Okay, so perhaps this one after we remove the irrelevant attribute, kita kata ni number metric act as an only identifier, so it's not meaningful to predict whether the student should stay or should be rejected or should be KIV on the application. Okay, this is the raw data. Perhaps so please check your data because neural network is really highly dependent on the data. If garbage in, garbage out, if the data is garbage, and the outcome will also be garbage. So we have to make sure data preprocessing phase is done very crucially and very thoroughly, and doing so to make sure the data that we want to proceed for learning is good enough, okay, to obtain a model from. Okay. Okay, since in neural network, if you realize it only involves numerical computation. Okay, so if the data is, so we have to make sure all the data entries are in numerical values. Okay, so if they are not, so we have to do some sort of data transformation. So this is one example of data transformation. Contohnya kalau male we transform to 1, kalau female we transform to -1. It's just example. You can 1 to 0 or 1 to 2. It depends on your preferences. Okay. So why? Because neural network only deals with numerical computation. Sebab tu nombor dia punya data which should be prepared in only numerical values. Okay. So we have the data that are ready for training or for learning. So we apply an algorithm. Okay. After the few steps, it depends. Of course, now we have hundreds of algorithm. I bet for neural network. So later we want to look for these. So the ultimate goal of this algorithm is to produce a set of weights. Okay, a set of weight that can associate, for example here, the attribute of gender to the result, the attribute of CGPA to the result, how much gender contribute to the result, of determining whether this application should be rejected, approved, or KIV. Okay, and how much CGPA contribute to result. Okay, so it's all about gaining the optimal set of weights here. Right. All right, that's for the learning part. Okay, and then comes the prediction. Of course, based on the set of weights that we have obtained from learning, that is our model. So now we can reuse our model in order to predict the future data. Okay, so this is, let's say, the future data. So as what we have done for the training data, the format of data should be also the same. If we process or no, if we remove the metric and the names, we also need to remove accordingly. Okay, so gender, perhaps we have represented to 1, so greater than 3 to 1. So that is the newly transformed data. Okay, so that is the prediction of algorithm. Alright. So weights dekat sini kita obtain the weights that we have obtained from the learning process. Itu yang kita tadi. In any learning, weights tu yang penting for that, because later we want to use to predict the future data. Okay. Only then. So of course now here it depends on the application. We have quite a number of function here. This is also, remember like last time I showed the activation function, a function to interpret whether the incoming signal, the total weighted signal is strong enough to excite or to make the neuron fires, or it just make the neuron only silent, do nothing. Okay. So we have many function here. We have binary step function, binary sigma function. Depends on the algorithm. Okay. So the role of this function is to interpret the activation of neuron, whether should the neuron fires, whether should the neuron fire or just idle or silent. Okay. Only then we can get the outcome, the prediction value of that new data. Okay. So that is the whole story. So from learning and until the prediction. So from learning, we perform any algorithm, and the final outcome of learning is the set of weights. The set of weights is to explain the correlation between inputs and the outputs. Okay, after we have obtained the optimal set of weights, and we apply for the prediction. There's a simple calculation here. Only then we can predict. So here the main important thing is weights here. Okay. What makes it different from one algorithm to another algorithm is the way we do the formulation to update the weights. Okay. But in the end of the day, the target of learning is still the weights. All right. So if you want to develop a neural network application, so you need to first know the basics of neural network. So the problem analysis, what is the task of the data, whether you want to the classification, you want to the, or you just want to group out the data. No need to know the or what we call the supervised value, the supervisory or the target value of the data. So it depends on the problem. Kita nak buat apa daripada data tersebut. We want to predict or we want to just to cluster the data. Okay, so of course we also need to choose the appropriate neural network architecture. Of course, there are many of architecture. So we should know the reason of having this kind of architecture, whether this one is suit with our data. Okay, the learning procedure algorithm, whether it's supervised or unsupervised. Okay, I will later explain what is the meaning of supervised, versus unsupervised. And again, like I mentioned, we need to go the data preparation. If your data is not good enough, so you might end up having a not so good model. It's not so good. I mean, not no, not good model that can perform and give you good accuracy. So we need to make sure the data is good as it can be. Okay, the data preparation. And then we also need to determine the activation function. Okay, what are the suitable function that we need to use in order to determine the activation function which one is to choose. But these are the basic thing if you, that you need to know in order for you to start doing the experiments of artificial neural network. Okay, and then in some cases you need to consider the biases and threshold. Biases like it's also serve as an input, but you cannot identify what is the input is all about. Macam bias tau. There some push factor for us to make some decision. So we need also some what we call it an external input bias. Tapi kita tak boleh nak describe what is the name of that input, but we can just term as bias, macam bias to force to make a decision. And also we also need to consider the threshold value, what on what level that we want this neuron to fire or just to keep silent. It depends on the activation function. So what we need to define some threshold as well. Also the weight initialization and update. Okay, so that's what I say in various algorithm it will differ. It have different algorithm of this one. Okay, some algorithm, yes, we can also start the weights from zero, but it will have a very slow learning, very slow movement of learning. Perhaps we need some sort of mechanism to determine what are the best set of weights to start with. Okay, and then later to update this value. Update meaning weight. To update weight means to perform learning, whether we should decrease the weight or we should increase the weight. Okay, so the weights update. And then whether this problem, this will need a linear problem or non-linear problem. We need to do some pre-analysis to the data. Whether this data is only for linear problem, otherwise we just go for the simple problem. We don't want to have a complex algorithm to perform on a simple data. So we need to make sure whether this is a problem of linear or non-linear. So you need to have some understanding on your data as well. Okay. So these are the key basic things that you need to consider for one who wants to develop a neural network application. But of course, nowadays we have many tools. You don't need to worry about to identify all these basic things from zero. We have already had a few frameworks that you can just use and adopt for a particular problem. Okay. So there's some idea of network architecture, macam-macam yang the computer scientists have modeled out based on the brain architecture. And this is the popularly one, the feed-forward neural network. From input, just move forward to the hidden layer, and we have the output layer. Okay, and we also have recurrent neural network. This one mostly meant for when you have data like time series data. This one is more suitable architecture. Okay, recurrent neural network. Of course, you have many more. So we have liquid state machine. It combines here. You have it combines the linear structure and with the non-linear structure, liquid state machine. And also we have the combination of the random sparsely connected network as a tree inverted neural network. Okay. See how now the idea of having such architecture depends on certain function or certain region in the brain. For example, the feed-forward neural network, it models more on the human brain sensory level, and the rest I think is more to upper level of the brain, upper level function. So it depends. Okay. Of course, we need to do a bit of study or reading in order for us to choose which architecture is more better for our problem. But these are example of among network architecture. Okay. Network architecture or network topology, okay, refers to the way neurons are interconnected to each other. It can be fully connected like this or like this, or it can have like a random connection. It depends. But all this architecture are inspired based on the brain, the neural biological system connection in the brain. All right. And the learning procedure, it depends, okay, on the context of our application. It can be a case of supervised learning, meaning in our data, for example, we want to do the classification. Classification is more like a supervised learning. In our data, for example, we have already had like we call it target, target that we have obtained in the past that already have the decision here. Kan patient with such age, gender, or particular sugar and hypertension, or in the past he or she has had a heart attack. Okay, yes, for heart attack. That is the supervised learning case. So bear in mind for supervised learning cases, you must have this result column in your historical data, and this kind of learning inspired the by what we call the Pavlovian learning. Dia dah orang dah buat eksperimen on dogs. When the dog was presented only with the food, okay, so it start to salivate, and then then later it come with a bell, but do nothing. Okay, the word did nothing, and then it come and uh, the experimenter tried to associate the bell and the food, okay, and later just the bell and the dog salivated. So meaning there is some uh, target here, okay, and what the dog can just simply associate with the target. Okay, that is called supervised learning. Or sometimes in your data, the task is not to classify. You just want to group your data. You want to cluster your data. Okay. So for example, for in business, we just want to segmentize. We just want to group or want to cluster our target customer. To which group should we go and do the promotion of certain products. So we just want to cluster, for example, a group of students in FKE, we just want to cluster based on certain attributes. Only then we want to, I don't know, we want to perhaps do more later, more for the study on this particular group. So that is what we call unsupervised learning. The main difference is that compared to the supervised, we have no target. Okay, we just want to group up from, or we just want to cluster the target. For example, you want to cluster, it depends. Generally, the clustering or the grouping depends on the similarity between each attribute. For example, this blue, red, or pink, red, and red, perhaps we can cluster based on the color, or perhaps we can cluster based on the numberless in the shape here, or we can also cluster based on the shape. It depends on the criteria or the attributes that we use to do the clustering. Okay, so generally the algorithm of clustering is to find the similarity between each data and only to group them out into particular cluster or algorithm. Particular cluster or groups. Okay, so there are quite a number of algorithms to perform the unsupervised. But mostly, I would say mostly in computing application, mostly the cases are unsupervised learning. Okay, so if the learning is supervised, so you need to have this previous. I mean, in the previous data, in the historical data, we need some. We need a target that has been made in the past. Okay. Okay. And the third one is reinforcement learning. Okay. People say that this one is more closer to human learning because we human we tend to learn from try and error basis, right? Okay. In reinforcement learning, there is no specific target for the learning, but we have some sort of rules. If the neural network give you the predicted output same as the target, so we give reward. Otherwise, we give penalize. When reward are given, mean that we need to increase up the association between the association between the weights values. Okay, and when there's punishment, and we need to decrease down the weight value. So that is how it goes. The learning. It depends on the simple rules as reinforcement learning. Okay, but this one is very complex to be implemented. It's not really easy as compared to the two previous learning paradigm. This one is more complex. Okay, right. So that's how for learning. So uh, in order for you to develop a neural network applications, we need to know which architecture is appropriate for your case and what is the procedure of learning that is more suitable, whether it's supervised, unsupervised, or reinforcement learning. But generally, people only consider these two types of learning, supervised or unsupervised. It's still new for their reinforcement learning. But yes, but there are some. Uh, Normally, those who want to develop games, I think most of them use reinforcement learning, gaming, okay, reinforcement learning because there are try and error basis and reward and punishment basis of learning. All right. So how should we view this artificial neural network in perspective of predictive analytics? Okay, as we know, we have many stage of analytics. Okay, we have the descriptive, diagnostic. Okay, this descriptive is just a surface, obviously surface summarization of data. We just summarize the data. Okay, then we have diagnose why did it happen, for example. And I think the most commonly used is the predictive analytic. What could happen? We want to predict the future based on the historical data. And then now if we even have no prescriptive, the cognitive yang ni dah advance lagi in terms of the evolution of analytics. Okay. So neural network could form starting from here, the predictive. See, the descriptive is more surface analysis for the data and go deeper a bit to the diagnostic, and then we have the predictive and later the prescriptive and then cognitive. Okay, but I think generally we are seeing now here at this level the predictive. Okay, of course, predictive analytics is a must. You need to have a data. Okay, from the data, you apply any algorithm and you learn or and you obtain a model. It depends model to represent knowledge. For a neural network, the model is a formulation consisting of sets of weights in order for you to use this weight later on to apply this new sets of weights to apply to the new data. Okay, that is basically the framework of predictive analytics. Okay, it depends on the algorithm, but the ultimate goal is to find from the historical data to obtain a model. Okay, what type of model depends on what type of algorithm, perhaps machine learning, decision tree, or any other machine learning techniques or neural network. Okay, it have different model. Okay, but in the end of the day, the model can predict the future based on the historical data that we have obtained from. Okay. Okay, predictive analysis, but you just feed a sample or sets of data to the machine, and now we expect the machine can obtain some using appropriate algorithm. We obtain the knowledge, or we obtain model from the historical data, and then we predict the future. It's about feeding the machine with some data for learning, okay, for learning and learning or training. Okay. For example, we want to write a program to distinguish a picture, face recognition. So we need to present to the machine. We need to feed the machine the data that consisting of a particular person in order to do the classification between these two persons. Okay, or perhaps we have a system that can to predict whether these sentences have a grammatical error or is a good sentence. So we need to present to we need to feed the machine with some examples of data having mistakes in grammar, or is a good grammatical syntax. Okay, it depends about feeding the data. Just same as problem 3. Okay, we just want to distinguish or classify whether this particular patient is to have whether this particular cell is a normal cell, is a good cell, or is a cancerous cell. Okay, so you have to have in the data example of cancerous cell and example of a normal cell. So so not only then, after we prepare a good set of data, then we choose the right algorithm to play around with the data, and in the end produce a model. So this model is to be used to predict the future. That is the idea of predictive analytics. Okay, learning is there, and from the learning you have, this is the framework of predictive analytics. Okay, this is for example Okay, the medical system, we want to predict, I don't know, to perhaps to classify whether this particular patient have some medical problem, whether there's some certain features. But of course, prior to do this prediction, prior to doing this prediction, we need to have learning from the historical data of some relevant data set. Okay. First, emotion detection, company need to present to the system uh, the features of anger, the feature of disgust, perhaps from the face we need to extract, I don't know, perhaps the eyebrows, the nose, or the mouth, or the lips. Those are the attributes to indicate, emotion. I think for now we have, we have six universally accepted, anger, disgust, fear, happiness, sadness, and surprise. Only then after we have done the learning of these emotion data, only then we can predict the new phase of emotion, whether it's going to be sadness, happiness, so on and so forth. Okay. So here are some scopes of A&M research. Okay. So perhaps there are people finding new learning algorithm. Some people like to formulate algorithm that is more closer simulating the human, which is the biologically realistic neural network model. And most of the selalunya ni orang from neuroscience, they tend to try to model the human learning as close as it can in order to perform the learning. But from my experience, the more biologically realistic the model is, the more complex learning it requires. Because there's some like a trade-off there. Lagi dekat dengan human, lagi susah you nak come up with the algorithm. And then some also are looking for simple learning rules. Okay, it's not complex, it's just a simple learning rules with just a simple mathematical computation, but still can serve for many tasks. Okay, and some also interested to do on so these are among research scope in neural network. Okay, and there's also studies to find what is the good weight in initialization. Okay, that's what I mentioned. Weights can also start from zero, but the learning can be slow. So how to speed up? So you need a good set of weight in order for you to start learning. Okay, and some also are looking forward doing the new learning with generic model. For your information, neural network is a high is highly dependent. Is data dependent model, I would say. Okay, the architecture that we have to structure out, it depends on the architecture of the data. So it's really data dependent. So it's not really adaptable, I would say, at some point to apply from one problem to another problem. So you need to customize accordingly based on the data. So that's why people are looking are looking ways to find what if we can have a generic model that can suit for all data. That one is going to be better. So we have a generic neural network architecture that can perform any kind of learning. That is one of the challenges in neural network. Okay. So if any of you are interested to pursue study in neural network, these are among I don't know, among potential area that you can venture in. Okay, in order for you to come up with good findings or novelty from the research. Okay. So the one in trend now is what? I think we have heard many application growing, from deep learning. So the beauty of deep learning, I think the motivation behind having people introducing deep learning is, and now as I mentioned earlier, like other machine learning technique, neural network also requires to be coupled with feature selection method. And they say what if we have to have an integrated framework that can integrate this feature extraction and the learning model. So that is the beauty of deep learning. It integrates, it integrates the parts of the feature extraction together with the learning, so into one framework of deep learning. So that is one of the motivation of having deep learning. But the rest, the learning parts, the computation of the multi-layer is still the same. It's more or less the same. What makes it different, that lies in the beauty of deep learning, is it integrates this both, so that it can solve certain issue when feature extraction methods. Okay. And the second thing is the curse of dimensionality. If you have, let's say, if you have more, if you have more layer, means you have more broad search space. Okay, so in deep learning, it has some. So when you can control the features for learning, and then you can control the curse of dimensionality. You can control the search space there. So that these are among um, two strong influences why people introduce deep learning. Okay, first is on the feature extraction method, the feature extraction part, and later is to solve some issue with the curse of dimensionality, to narrow down the search space by having a good feature extraction portion. Okay, and this is a deep learning. It's still the same. You have the architecture, but yeah, one have more layers now. Okay. Okay, it's still using the same learning algorithm. I think most of the algorithm is still using the back propagation algorithm for the learning. So what makes it different is to integrate that, it integrates the feature extraction part. That is the beauty of it. Okay, and the most commonly used is the CNN, the convolutional neural network. I think we have had a talk on deep learning, right, Helmi? Before this, I mean, another in the previous session. So I think you have had some idea on what deep learning is all about. Okay. Okay. See, we have a layers. We have layers of convolutional and pooling layer just to optimize the features. Okay. Only then we have the fully connected to perform the learning. So that is the beauty or the advantages of deep learning. It comprises, it can control the feature extraction part in order to fit into the learning part. Okay. So now we have growing interest or growing applications of deep learning. Semua orang cakap pasal deep learning. Tapi for me, it's not really a really new paradigm. It's still the same, but I think what makes it good is it can control the feature extraction part, so it can optimize more the relevant features. Okay. So we have tools, and we have many tools and framework now. No, don't worry. You no need to you no longer need to uh, pull your head out to start doing the programming from zero. We have many available tools framework. Even in SPSS, we have already had you can still do the neural network kan using SPSS. Dia ada modul yang I'm not mistaken ada kot yang back propagation tu ada dalam SPSS, the statistical tool. Okay. And letters, of course, people using Python. There are many libraries there for neural network. You have SKIT learn. I think yeah, Python on the machine learning, and the neural network is also in there. You have TensorFlow, you have PyTorch and Keras to do. I mean, these are the framework for deep learning. Okay, of course, there are many open source now. So these are among the available. So those are, I think most of them are open source. Can you have a look? Okay, so here are some examples I mentioned. Okay, example of neural networks in bioinformatics. Perhaps we can have a good set of gene data, and we can predict what is the best combination of the genes in order for us to to do some genetic mutation. I bet. Okay, genetic mutation apa dipanggil? Genetic engineering. Okay, or we can also predict the best combination of chemical in order to form drug. So nanti mungkin ada kot, when we have a good set of data, maka ada orang keluarkan macam how to predict a good set of combination, I don't know, drugs to do the corona vaccine. All right. So in agriculture, okay, of course there are many things. You can also do the forward marketing. Okay, for marketing, you can, if you have appropriate data, you can predict the market of your agriculture. And now we have we have with the availability of meteorological data, kita dah boleh predict climates in order for us to use for the agriculture. Okay, and this one mainly we have crop disease detection. Okay, kita nak tengok. I think using appropriate IoT we can already just use phone to scan daun pokok tu, then we can say, oh, this one is berpenyakit, or this one is okay. Okay, and the irrigation scheduling to optimize the resource, so we perhaps we can schedule systematically the way we do the irrigation for the plant. Okay, so these are among examples of neural network that we can develop. Okay, of course, in business, we have many things, profit analysis, we can predict the market segmentation, the consumer behavior analysis. Okay, so we can predict, when a customer pattern like seems like a certain product, so perhaps we can predict what are the types of customer that are going to buy that same product as well. So this can be beneficial for your business venture. Okay, so of course there are many things that we can do in business. The market segmentation, for example, like as I gave earlier, we can segmentize our customer so that we can do appropriate promotion to target customer in order for us to launch our product. Okay, for hash screening, okay, of course many neural network applications that have been developed that can be around this hash informatics. Lifestyle advisor kan sekarang dekat phone kita boleh tengok, we can see, okay, dia boleh target, okay, how much calorie do you need for today and how much left, makan nasi lemak pagi dan habis dah kalori contohnya. So these are kind of lifestyle advisor. Okay, of course in social media we have very good pool of data. Okay, I do have my student are doing on hate speech detection, using the data, how to guide. Okay, so of course social data, social media data, and the social studies doing to obtain the sentiment analysis that we can using neural network to classify whether the sentiment is what, the negative sentiment or the positive sentiment or just a neutral sentiment. So yes, using the social media data. Okay, we have many pool of good data here. Okay. Okay, and human aware system. Okay, we have current system. We have robot that can interact with human. Or we have, like now we have smart house, we have more intelligent environment that can control house or building, okay, using neural network as well. And now we are now developing more humanoid robot, I would say human robot yang lagi dekat menjadi human yang boleh, so that for the robot can best interact with the human, the social robot. So these are, the engine behind is on neural network. For example, perhaps this robot can identify the emotion of this girl. So it needs to be trained priorly. What are the emotion? What are the certain emotion? Whether it's happy, whether this particular person is happy or sad. So you need to be fed with the data, the appropriate data, and learn and get a model of sad, happiness, so on and so forth. Also, you can also venture into human assistive technology. We have gloves that can translate sign language to speech. Perhaps the machine should be fed with a set of data of movement, sign movement. Kalau macam ni, that to represent certain words A, B, adalah dia punya sign language, and it can convert to the speech. So those are the engine behind. Okay. And now we also have neural network that can learn the brain pattern, the EEG signal for some particular task. For this one, for example, there is it has been found that there is some particular spatial pattern if we are looking to the right, if we're looking to the wrong, to right and the left. So based on this signal, so we can predict, perhaps for this with speech problems, so can also still communicate, okay, using just by apa kita kata brain reading, dia kata brain reader sekarang, system that can understand your brain pattern. Okay, so here are some examples that some ongoing research under my lab. Okay, we are doing the using the echo-set neural network, another architecture of neural network, in order for us to identify the network intrusion. Okay, we have teamed up with, for those experts in networking, okay, and to classify. And then the data, echo-set network best deal with the time series data, so that perhaps instead of because in the existing application of intrusion detection, you can only classify whether this particular is a threat, a technical threat, or just a normal packet, I would say. Okay, but instead of just to classify, perhaps we can predict ahead bila threat ni akan berlaku. Is there any pattern? Whether they boleh attack at a particular time. So we can as well, using this echo-state network, we try to predict. It's not just to classify what type of attack, and we can also classify when this is going to come. Okay, this intrusion. This one is the ongoing. Okay, we have the grant from Mohin, different and FRGS, and under the field of cyber security. Okay, and currently we are doing on deep learning on facial recognition. We said for the COVID application, we got this just an internal grant for the COVID grant, just for tracking and early screening of COVID. We just want for the tracking, we want to trace for those who violate the quarantine rules. So perhaps we can give alarm to the authorities in order for us to do the tracking. Okay, these are among applications that is under development. Okay, and we also have multimodal sentiment analysis. Okay, also using deep learning, because as we know, any machine learning, any neural network, the nature is black box. Kita tak boleh tengok behind. It cannot reason out why does it reach certain decision. So that's why we want to improve the model of deep learning in order to integrate with some fuzzy elements. So in order for us to have a more explainable deep learning, so that people can know it's not just the decision that has been made, is to reason out behind what was the reason that have been concluded from the prediction. Okay, so I guess that's just, I think, I'm not sure it's taking a bit of time, but I think just give some idea for you to know what neural network is all about. Okay, some examples application that you can do, the tools available there for you to use. Okay, but what I can say, neural network is now it's not really, I mean, it's not really it's not really a rare or new, I would say, a new method, but becoming a benchmark method, particularly for some, for example, the back propagation in the algorithm is now can be served as a benchmark method for any machine learning technique. So it's not nothing. Okay, so with that, I thank you, Hami. So perhaps we have more time later to explain further on particular issues on neural network. For those who are interested, can just contact me at any time. Can you reach me here at IB? Okay. Yeah, Hami, over to you.
Okay, thank you very much, Dr. Nooraini, for the very interesting talk. So many new things that I learned from this talk. All right, so is there any question from the audience? We have we have about 48 audience for this talk. Any question to ask, please? Anyone? So that must start my first question to Dr. Nooraini.
Yes, please.
How do we know that this model is suitable for clustering or any clustering or prediction?
First, First, you need to know what do you want to do. You need to understand your problem first. Is it just meant for? Is it meant for classification or is it meant for clustering? Okay, but under clustering, there are many algorithms that you can choose. Okay, it depends. So in terms of algorithm, which one you will prefer? Is it the complexity, or you want to go more for the, I don't know, it's more biologically plausible. It depends on the context of your data. Okay, it really depends on the data. But I think as far as I'm concerned, for clustering, we have, for example, cohortant, we have self-organizing map. So those are quite typical unsupervised learning. So basically it goes back to basic. You need to know your task and understand the nature of your data.
Okay. So any differences between the classical neural network models with the spike neural network?
Yes, as I mentioned in the classical neural network model, tadi kan dia rely on the Hebbian learning rules yang the original Hebbian.
Yes.
In the original Hebbian says the philosophy behind is that if one single neuron fires at particular time t1, and there's also other neuron fires at the same exact time, uh, t1 as well, but on neuron B, so only then there is some correlation between A and B. Okay, but in the spiking, because based on the philosophy that actually the firing of neuron in human, actually there's some delay. Dia bukan actually at T1 and T1. Actually there is some gap of the activation of neuron. For example, if the neuron fires at time T1 and within an acceptable range of time T2, there still exists some correlation. So that is the obvious philosophy um, between these both. And because of this importance of time in the spiking neural network, so the spiking neural network is busted with time series data. Okay, because there is some element of time that is important in the computation.
All right. So thank you. So any question from the audience?
Yeah, for those who are interested to further study neural network, of course there are many aspects still there to venture. Banyak lagi benda yang boleh di explore. Okay. But of course,
Okay.
that's what I say now. The trend is deep learning. Semua orang go for deep learning. Macam dah jadi apa ni trend yang
Ada soalan dekat chat tu Dr. Nooraini.
yes. Sorry. I overlook this one.
To what extent does ANN architecture use impressive potential to iris recognition detection and biometric application among patients of autism, for instance?
Yes. Macam mana? Can you repeat again? Tak tahu.
To, to what extent does ANN architecture yields impressive potential to iris recognition detection and biometric application among patients of autism, for instance?
Yes, I think yeah. I have heard some application around the autism, perhaps to detect the EEG signal. But for iris, I have heard, but in autism, yeah, I think it's still a new idea. But for iris, I think they're used for EEG, brain signal tu kan, kuning neural network. But I think yeah, I think it's still a new idea on using the iris, perhaps to detect the attention level kan yang budak-budak autism ni, whether he or she can focus on. Yeah, I think it's still a new idea.
Okay. Any other question from the audience? All right. So if there is no question, so thank you very much for the Dr. Nooraini for
Yeah.
your time and good sharing to us. And perhaps we can do further talk after this.
Yes, sure.
Thank
So
you very
anything you
much.
can just reach me.
Yeah. Thank
All
you
right.
very much. Assalamualaikum warahmatullahi.
Thank you so much. All right.